Look at metric prefixes. Out of all these, you really only need to know a few of them. Okay? You don't need to know them all. No one's ever going to really talk about a yada or a zeta or an x or a beta. So for these, you don't need pretty much through here at least for sure. Now, for computers, if you're a computer nerd like me and you want to know about them, you definitely want to know that range right there. This is computers.
Wait, so we're just not going to bother with the top four?
Okay, no, the top four you're never going to see unless you go into like astrophysics or something. I mean, look at the number. F.
I don't even know how to say that.
Yeah. I mean, there's no, I don't even know either. We got billion, trillion, zillion, I don't know if that's even a number. And after that, we're lost. What? What?
Yesterday, Miss Starks asked us what are non-real numbers, like non-real numbers, and I was like, first one was like 55.
You know how to get on her nerves, don't you? All right, next, here. You're going to need this section for sure. You really don't need hecto, deca, and deci. Nobody really uses those either. Pico sometimes, but pico's really small. I mean, we're at the stage now in the world where pico is usable, so maybe we can include that, but you're not going to see much of pico. It's really small. Pico the guy. Okay? Now, great that I just said all this, but what does it actually mean? What does it actually mean? What does all this mean?
Numbers.
Yeah, what are they though?
They're numbers.
Why? Why are we using them?
Because some are too big and too small to,
Okay, some of them are too big and too small. So what do you mean too big and too small? To do what?
to explain what it is.
Yeah, to express the number. Nobody wants to write all those zeros, right? Do you want to say like 200 million kilometers? No. You would use a much higher number. You would use tera or terameters. In that case, you might even go to light years. But you're not, yeah. But you're not going to ever say something, where the number gets so large. It doesn't make sense. So prefixes are used to help us. You know what I think of prefixes as? There's an analogy to something in English. What is a prefix like in English? In the English language, you use something to make things easier to write and to say. Okay, similar. It is an abbreviation, absolutely. Sorry. But I'm talking about a grammatical punctuation that you use when you write to make things smaller and shorter and easier to say.
Period.
A contraction, an apostrophe. So you know when you put like can't instead of cannot, or won't or don't? A contraction, that's kind of what you're doing here. Just making it easier on yourself. That's why you use contractions, right? You're told not to, I know. When you write, you shouldn't actually. Is that correct? When you write? But when you speak, you use them all the time.
I speak proper English.
No, you don't. You absolutely don't. I've heard you speak English. Now, anyway. Kilo. Where have you heard kilo before? Kilometer, or kilometer, but kilometer is the way most people say it. Centimeter, millimeter, micrometer, nanometer, picometer. Meter is the easiest thing to use. Everybody knows length. Nobody knows things like mass. I mean, kilogram, sure, but centigram, nobody really says much of. Milligram, prescription medicine, CVS, milligrams. Micrograms, no. Nanograms, I mean, now you're getting into like quantum, small level stuff. So you're not going to hear that with gram. But with meter, you hear it all the time.
Like iPods.
Yeah.
Like
The nano is the smaller one, right? The iPod, no, it was mini. I thought it was million. The mini came out first, right?
Yeah.
No? Did you guys have the mini? That never
It
existed?
came out before the nano.
Okay, yeah.
This little guy.
The nano. Next is Pico. Pico's going to come out, you like put it under your skin. You're like, I can hear the music in my ears. It'll happen soon. All right. Now, what do these numbers indicate? What do these numbers on the side indicate, really? Why are they used?
How many zeros?
Very good, Av. How many zeros? So if something is a multiple of 1,000, like a kilometer is 1,000 meters, you can also write it as 10 to the third meters. 1,000 is 10 to the third. A million is 10 to the 6. A billion is 10 to the 9, etc., etc. Questions? All right, let's move on. Oops.
I caught Mr. Howell talking smack about me one day when I was sick. He was like, good thing Helen said you were getting a lot done.
That is probably true.
It is true. And then I sent him an email and then deleted it.
So next to kilo, again, write down 1,000. Next to... It's okay. Bugging out. There we go. Now, on the second page, we're going to talk about scientific notation. Now, I want you to think about this. I do not want you to memorize rules that you learned in the past. I know it sounds really stupid because you're like, spend all this time remembering left means this and right means this. Forget it. I'll show you a way that's so much easier. Okay? And it helps you understand what's going on. Tell me, what is the number one rule about scientific notation? You make the number into what kind of form? What does it look like? What is a characteristic of scientific notation that you're trying to do with that number?
Exponential.
So you have something with an exponent, good. What else?
Like x times 10 to whatever number.
Okay, good. What is x, though? That's what I want to hear more about, this x.
Any number. So like the first one.
So it could be 38,000. I could leave that times 10 to the 7.
No.
So what about x is a characteristic of it?
It has to be
What? It has to be what? Something.
like less than 10.
And greater than?
0. 1.
Good. It needs to be between 1 and 10 exclusively. Partially exclusively, partially inclusively. For example, you could have 1 times 10 to the 8th, so you can have 1. But you can't have 10 times 10 to the 8th. You have to have like 9.99. You never have 10 there. So it ranges from 1 all the way up to 10, not including 10. Agreed? Again, always. So for the first one, if I see 3,400, what can I make that instead? Just give me the number part in the front, not the exponent part. Just the numerical part. 3.4, very good. Now, everybody knows that you write times next. Everybody knows you write 10 next. This is the part where everybody says memorize. Don't memorize. Here's what you do. You look at this number and you say to yourself, to go back to the original, does it have to get bigger or smaller? Bigger. Agreed? Therefore, this must be positive. Positive means bigger, doesn't it? If you had a number here, like we're going to see in a moment, and this would be 2.3 for this one, to go from here at 2.3 to here at 0.00023, the number has to get bigger or smaller. Therefore, this exponent will be? Isn't that so easy? So forget left and right if you remember that. Now, you still have to count the amount of decimal spots. But that's not tough. You can do that. Okay? So here we can say 1, 2, 3 spots. This one, 1, 2, 3, 4, 5 spots. Does everybody agree with what I just did there? Again, you take the decimal, you move it 1 0, another 0, another 0, another 0, and then between the 2 and 3. That's 5 spots. Since it becomes a smaller number, you make it a -5. This decimal, you move 1, 2, 3 spots. Since this becomes a larger number, you make it a +3. Questions? We're good? You've seen this, right? Chemistry, biology. Good. Finish the rest of them. Go ahead.
I don't have that sheet. I downloaded the thing. But it's in the
They're 2 separate files.
Oh.
Go back to Moodle. Finish off the rest of them, please.
Which one is it? Dimensional analysis.
What did you just? Dimensional analysis.
Yeah.
Okay, open a new tab. But then when you open it there, you can add it to the existing file. Add to the note. Add to the one you're working on now. So what you're going to be doing is you're going to take these numbers here and you're going to make them into scientific notation. Have you seen this before? Okay, so I want you to do them while you're here. So do you want to write with this? Do you have a stylus? You're going to use your finger? Is that good? Okay. Who's missing today, folks? Who's missing today? No, it's not. Oh, you know what? Erica's not in this class anymore. She moved into the honors section. She was in honors math, so she was supposed to be in that section. I don't know how that got mixed up.
Default dropping the ball.
Oh, there you go. Has everybody met Tala? Has anybody met Tala? You
Yeah, she's in my mentor.
Okay, cool. So this is Tala. She's in this class now, obviously. Be as nice to her as you are to me. Actually, much nicer. Tala, do you have a free period all today? You happen to know? Or if you're sitting check? Because maybe you can come by and I can go over some stuff, like the syllabus and just how to work it and how to get access to your normal page.
This page is so light. I'm like,
I didn't free it also. I free it over once. So do you know where at the end of this hallway is the math and science office? And you just come by for like 10 minutes. Is this your lunch period? So maybe eat first. So you make sure you eat, and if you have time. If not, we'll go over tomorrow. How are you going to eat? So make sure you do that first. Okay?
Mr. Hall, you know where we're meeting Mr. Joseph to get jerseys and stuff? Coach's office.
Probably there or the locker room downstairs. I mean, Commons. That general vicinity, you know? It wouldn't be up here. He's not going to carry boxes of clothes up here. Okay. Number 8, obviously, a lot of you can ask, well, you don't have to change it. You could write times 10 to the 0, or you can just leave it alone. You don't really have to write 10 to the 0. Okay?
On this one, do you copy this? And then here,
You're good?
oh, is it like
Yep, that's perfect. Now, if you want, listen, folks.
it's possible to
Don't remember rules. What did I tell you? Look at this number. To get from here, watch. Can I write? Can I use a different color? To get from here
Is number 8 already
to here, does it get bigger or smaller?
bigger.
Is bigger to you in your mind positive or negative?
Positive.
So make this positive. Please remember that. Don't remember left and right. Trust me. Because on the test, you're going to have nervous and you're going to be like, I forget. I don't know what to do. If you understand it, it's better. Reese. If you want to do part 2, you can do that. Sure, yeah. Hey, folks, one thing I want to mention, and this is different from your last classes. I'm not really going to worry about significant figures at all. So, take a look at number 5. If you want to put 4.5 times 10 to the 1, that's fine. In physics, we really don't go any further than the first decimal spot whenever you're going to use scientific notation. If it's a number like 300 kilograms, you're not even going to use scientific notation. So this number really, you wouldn't write it like this. You would probably just write 45. You know what I mean? It doesn't really matter that you put it in scientific notation when the number is so small. It's just for exercises. That's all we're doing this for. Just to practice. Nick.
It would be counterfactual if you just write 4.501 times 10. Would that be?
Yes, absolutely. Absolutely. If you are more precise, I'm not going to take off. No, absolutely not. Now, Nick, there becomes a point where it's like tedious. Like Avogadro's number, 6.022 times 10 to the 23rd. There are 25 more decimals that are not 0 after that. But are you going to write all of them?
No.
Okay, so that's where you have to start using your, intuition and physics together.
Okay, thank you.
Yep.
Wait, Mr. Howell?
Yeah.
This log, I fill this out every day.
Only when there's a question. So as you're walking around, if there's a quick question, if it's something like really basic and you don't really worry about it, no big deal. But it's something that I might want to know about, like a question they asked that maybe everybody else would have, just write it down on there.
Oh, okay.
Does that make sense?
Yeah.
So you don't have to put just put your section number and teaching assistant there. But you don't need to put a new one every day. You could continue running on this and just keep adding more pages.
All right, and then when I grade a problem set, I have to fill this out for each one? Or is it just if there's a problem? Or is this for all of them? Oh, this is for all of them, right?
So, okay, here's what I'm going to do. So Fernando is my other TA. He's only in class 2 or 3 days a week. So I'm going to have him grade physics for that class and
okay.
to make up for the fact that you're really working class. He's not, you know what I mean?
Yeah.
Should be same credits. So you're only going to have to do physics for the section, not both.
Yeah, but
I know,
When I
I know.
fill this
because-
out. Oh,
because
so
last
I'm
year
not
I
gonna
gave it
fill
to
this
Matt.
out?
You are, you're just gonna do one of the sections.
Oh, all right. That's fine.
Sorry.
No, no, no.
that's good. I put 2 sections in hand in both.
All right. Ned's an overachiever.
No, because, well, Hannah did both math. and
No,
then
I
both
don't mind
math.
doing the problem sets.
Yeah,
Like, I like to diffuse actually.
I'll give you, for sure this class. Maybe I'll give you like half the other class every once in a while.
Yeah.
Because then he's doing 2 full classes at my math class. It's not bigger.
Yeah, you're the you will
So, for the most part, I won't, but I'm not usually stickler about like getting it back quick. What I'm going to have to do is give you access to all the Dropbox. So don't be messing around with them. Any questions on any of these? You want to raise a hand if you have a question? Thomas, which number?
No.
Okay.
Part 2.
Part 2, sure, you can go on to it, yeah.
Already finished one.
Yeah, some of you might be done with part 2 already.
Chocolate Chunk thinks he's the man right about
Oh,
now.
wait, no.
That's what you say. Okay.
Are you good? Do you have any questions?
No.
Okay. If you're done, you can look at the next page. We're going to talk about dimensional analysis in a minute. You're welcome to get a head start. Nice, very nice. How you doing, Tava? Good? Okay. Make sure you ask if you have a question, okay?
No, that's the next page. We'll do it in a second.
Correct. Because if you put it anywhere else, it wouldn't be between 1 and 10, right?
Yes.
And that's the whole idea. Any questions you noticed? All right.
This sucks. They did it in
I have to do it, you know that.
Yeah.
Because if somebody doesn't, and the next part is the part with the units, dimensional analysis.
I love that.
Yeah. Okay, so for this page here, please follow the instructions I'm going to give you. Because although it might be easy to convert simple units, it is not easy to convert units when they get more difficult. For example, density is measured in kilograms per cubic meter, or grams per cubic centimeter, or what do we have in English units? Slugs per cubic liter, which we never use. A slug is a measurement of mass in the English unit system. Now, imagine if you were converting between those units, right? It'd be very difficult. It's not like converting inches into feet, where you just say, all right, well, I can divide and multiply by 12. That's easy. So for those, sure, you can do that in your head always. But for units that are more difficult, I want you to follow the steps I'm going to give you. And it'll make it a lot easier on you. Okay? So let's go ahead and do this. I'm going to give you the first example, and then see how you do with some of the other ones. So the first one, we're going to convert days into seconds. So you think right away, my starting point is days, my goal is seconds. Can I do that in one step? It's difficult. There is a number that you could just figure out and multiply by to give you the answer. But it's not going to come to your mind second nature, right? So you do it in steps. We break it up into little components. Reese. Okay, now, Reese, it's not right, but you're close. But the reason I want to correct you right now is because I'm going to show you a way to do it that will completely rule out the chance of you making that error again. Okay? So now, for your example here, specifically now, you'll see. So, go ahead and write 2.83 days. Okay?
Yeah.
You know what you did?
No, I'm pretty sure I got the answer right.
No. You do not divide by 24, absolutely not. Reese, you're going...
Just 24 by itself and then divide
No.
by 60 and then divide by 60.
But you're doing it wrong.
No.
You're using the wrong operation. Help him out, folks.
It's multiplication.
It is. It's all right. Don't worry. We're in class now. It doesn't happen on the test. You're good. Watch what happens. Look at your units.
Smaller than that. If it's going to be seconds, it obviously has to be bigger than the number of days.
That's exactly what I was going to say. Very good, Helen. Use intuition. Seconds. If I convert days to seconds, aren't there a lot of seconds in a day? So it's going to get bigger. So you're not dividing. You see that right away?
Yeah.
Now, Reese, don't even worry about it. Because what I'm going to show you now, you won't have to think about it.
Okay.
Think about the first beginning part here. Where are days right now? If I thought of this as a fraction, what would it be over? What's everything over?
1.
Good. Where are days currently? In the numerator or the denominator? So if I want to get rid of something mathematically, if I have it in the numerator, where do I also have to have it? So put days in the denominator. What am I converting days into, Reese?
Hours.
Good. Hours is my first step. How many hours are in a day? So where does the 24 go? Up top. How many days? 1 day. Now you will never forget how to do it. Because if you just do it this way every time, look at your units. Cancel, cancel. So now we're in hours, but I don't want hours. What do I want really? So I got to go somewhere else after hours. Minutes. Give me the conversion factor, somebody, please. In. Why did I put hour in the bottom? Because it was up top up here. And now it cancels. And like magic, it works again. Go to seconds and you're done. Take a look. What do you have left right now? What's the unit you have, F? So isn't that where you wanted to get? And don't you have a bunch of fractions? What do you have to do?
Multiply.
Look at your symbols. Multiplication, multiplication, multiplication. So multiply all the tops. That's your numerator. Multiply all the bottoms. Well, what do the bottoms all happen to be? Coincidence, not coincidence, making it easy. In a moment you're going to see that's not always that way. Sometimes the bottoms are different numbers. So multiply across the top and see what you get. Somebody come up with a number and raise their hand, please. And my units would be seconds, obviously. Elliot.
2.45 times 10 to the 6 seconds.
And he expressed it in scientific notation. Okay? So you're looking at like 245,000, something. I didn't say to, so in this case it doesn't matter. I would agree with him though. The minute it gets to be in the millions, you should probably use scientific notation. Anything, here's my rule of thumb that I use. Anything that is like 10,000 and less, I leave in standard numerical form. Once you get to like 100,000, you start to use scientific notation. So if you could express it times 10 to the 5th or 4th, I would do that. Okay? I would go ahead and do that. Number two. Number two is easy. It's too easy. All right, let's go to number... Oh, these are all pretty easy right now.
Do this one, number 4.
Yeah, let's do number 4. Or, you know what, let's do number 3 because it's in scientific notation. We'll do that first. Leave number 2 blank, or if you've done it already, that's fine. I'll have you do it tonight, so if you've already done it, that's cool. Let's take a look at number 3. Weeks into seconds. What did we do a minute ago? We converted what into seconds? So what's the only difference? How many days are in a week?
7.
So these conversion factors, 24, 60, 60, those are going to remain the same, aren't they? But we're going to have a 7 in there now. So I could redo this whole thing and show all the units again. Or I could say, you know what? I could just take this quantity right here, and multiply it by these 3 conversions, and in addition, or also, not addition meaning sum, also multiply by the number 7, and you would get the right answer. So you could take this quantity, multiply it by 7 to turn it into days, and then just multiply by these 3 to get it into seconds. Do you see how I'm using my previous answer to help me out with this one? I'll show you what I mean in case, real quick.
Yeah, you have to go in the same order, right?
Doesn't matter. Multiplication is commutative. 5 times 7, 7 times 5. Same answer. No. This pen is not working. This tip broke.
Oh no.
Thank you, Mike. Is it firm or... Okay, that works. Jesus. Okay, so the only difference, it's probably just me, The only difference here is that we have this 7 days per week. So the numbers remain the same. So you can just use what you have already done. Don't do more work, right, than you have to. Use shortcuts. Help yourself out. You're going to see this year that I'm going to talk about what's called solving generically for answers, which means that you solve for the answer in terms of the other variables. So, say you had an equation that was like 2x plus y minus z equals w. And I was like, solve for z. You move all the other variables around, right? It's called solving generically. This year you're going to do that a lot, so that if you solve generically once, you can reuse that generic solution with just new numbers, or a new scenario, or a new situation, considering the fact that it's only difference by 7. Okay, make it easier on yourself. You remember doing that a lot? Generic solutions? Alright, how about number 4? How about number 4? What does kilo mean? What does kilo mean? Reese? 1,000. So when you see kiloliter, you say 1,000 liters. So you have a half of 1,000 liters. Right? That's what that says here, a half of 1,000 liters. What is that? How many liters? 500, right? Now let's say you forgot how to do this. Just go like this.
Wait, for a question, say that was like on a test. Like, because I know it's kind of obvious.
Yeah, you don't need to show work.
Alright.
Half a kiloliter. I want to get rid of kiloliter, right? And I want to turn it into liter. There's 1,000 liters in 1 kiloliter. So really, what are you doing? You're just multiplying by 1,000. What happens to your units, people? The number gets bigger, but what happens to the units of kiloliter? They cancel out. So remember dimensional analysis that we just did with converting units in time? It applies the same when you're converting from one metric to the other, just by getting rid of the prefix. So again, kilo means 1,000, so I put the number 1,000 right there.
What's wrong? You heard King Henry thing.
Did you guys learn the King Henry thing? You can go and move them over. If they learn it that way, I'm going to let them. I'm not going to go through it. But if you want another way of learning this and you have trouble and you want to ask Helen to show you something, she can do it. Okay? For now, though, I want you to think about what the word means. What the word means. Kilo means 1,000. How about the other ones? Go back to your first page, please. Go back to those prefixes on the first page. The metric system prefixes. Okay. So the ones that we said to use. In physics, you're going to use kilo. You're not going to use mega, giga, and tera much here. But you'll definitely use kilo. Next to kilo, write down the word thousand. Thousand. Okay, next to kilo, write down thousand. 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 Next, go down to centi. Centi. Next to centi, write down hundredth. 100 with TH at the end of it. HUNDREDTH. Hundredth. Next to centi, you're writing hundredth. I'll go back and add it to the recording. Start with 60 kilometers per 1 hour. Okay? That's why I did the fraction before. That's why I put it over 1. There happened to be no units in the denominator earlier, but what do you notice here now? There are units in the denominator. The units are hours. So we need to get rid of those units as well. What do we want to make hours into? And we want to make kilometers into? Good. Does it matter which one I do first? Why? Multiplication is? Commutative. Good. Commutative. What do you want to do first, Mike?
I'll do hours and seconds.
All right. So let's put hours up top. Why? Because hours were currently in the bottom. Remember before when it was up top, we put it in the bottom? Now it's the reverse. I want to get rid of something in the bottom. Put it up top. So we got hours into what? We're going to put that into minutes first, right? So what do you notice now? Where did the number go? Yeah, it's in the bottom. So we're going to be dividing in this problem, okay? So at the end, we're going to have to multiply across the top, multiply across the bottom, and then divide our answers. We have something in the denominator this time. That's why I wanted to do this example. Hours are done. I want to get rid of minutes. So I put minutes. What do I put in the bottom, Tom? Good. How many seconds in a minute? Another thing in the denominator. Look at that. Okay? So what do you pick up on? When you want to change a unit in the denominator, you're going to get some numerical values probably in that denominator. Now, how do I get rid of kilometers? What's my conversion factor? Who wants to help me out here with this last part? How do I get rid of kilometers? 1,000 what?
Kilometers.
Meters. Thank you. So where do I put that? On the top or bottom? 1,000 meters per 1 kilometer. How come? Yeah, we want to cancel those KMs. Cancel, cancel. Okay, so kilometer was up top here. Was up top here. So to get rid of it, we put it down in the bottom there. So what do you notice? You're going to have, conveniently, some cancellations. Why don't you cancel one of those 60s, right? Why would you multiply across? In this point, cancel this 60 with this 60 here. And then your answer is just 1,000 over 60, and you're in meters per second. There's seconds, there's meters. Okay? Finish this page up tonight, please. Tomorrow, bring in a cylindrical object, like a soda can or a Lysol can like this, but don't bring a Lysol can. I have it right. Hey, bring in a cylindrical object. We have a double period tomorrow, correct?
Yeah.
Lab, okay? It's in here for 2 periods. You got a break in between.
See you later, Michelle.
Have a great day, everybody.